Okay, let's be honest. You've probably used the words mass and weight like they're the same thing your whole life. But what if I told you that in the world of physics, they mean two completely different things? Today, we're going to clear up one of the most common mix-ups in all of science. Think about it. You step on a bathroom scale and it spits out a number. But what is that number really telling you? Is it your weight or is it your mass? Well, the answer might actually surprise you, and it all boils down to one of the most fundamental forces in the entire universe. So, to get to the bottom of what that scale is measuring, we've got to first figure out what weight actually is. Because it's not just a number, it's a force. Specifically, it's the force of gravity. And here it is, the most important thing to get your head around. Weight is really just another name for the force of gravity. It's not something that's inside an object, it's the measurement of the Earth's gravitational pull on that object, yanking it down toward the center of the planet. It's such a simple idea, but it's so powerful. Seriously. From now on, whenever you hear the word weight in a science context, your brain should immediately think force of gravity. They're one and the same. So how do we actually calculate that force? Well, we use this beautiful simple equation right here. The force of gravity, or weight, equals an object's mass, that's the m, times the acceleration due to gravity, which is that little g. This tiny formula is the key to unlocking this entire concept. Okay, so if weight is the pull of gravity, then what in the world is mass? This is where the big mix-up always happens, so let's just break it down side by side. This chart really lays it all out. Over on the left, we've got mass. Just think of it as the amount of stuff an object is made of. The crucial thing here is that your mass is constant. It's the exact same whether you're on Earth, the moon, or floating in deep space. And we measure it in kilograms. Now on the right, you have weight. That's the pull of gravity on all that stuff. And because gravity is different in different places, your weight changes. Since it's a force, we don't measure it in kilograms, we measure it in newtons. All right, let's jump back to our formula for a second. Because the real secret to finally getting the difference between mass and weight, it's all hiding in that little letter g. Right here on the surface of our planet, the acceleration due to gravity, our g, is pretty much always this constant number, 9.8 meters per second squared. You can kind of think of this number as the strength setting for Earth's gravitational pull. If you were on, say, Mars or the moon, this number would be totally different, and that's exactly why your weight would change. Okay, that's enough theory. Let's see how this stuff actually works in the real world. It's time to put our little formula to the test. First up, we've got an airplane with a mass of 4,500 kilograms. That's the amount of stuff it's made of, right? So the question is, what's its weight? All we need to figure this out is its mass and that magic number g. So it's super straightforward. We take our formula, Fg equals mg, we plug in the mass, 4,500 kilograms, and we multiply it by our gravity constant, 9.8. You run the numbers and bam, the airplane's weight, the force of gravity pulling it toward the Earth, is 44,100 newtons. See? Simple as that. Okay, now let's flip this problem on its head. This time, we know an elephant has a weight of 25,000 newtons. So the question is, how much stuff is it made of? How much mass does it have? We start with the exact same formula, but this time we need to find m. So with a tiny bit of algebra, we just rearrange it. Mass equals weight divided by g. We plug in 25,000 newtons for the weight, divided by 9.8, and we find out the elephant's mass is about 2,551 kilograms. It just goes to show you how useful that one simple formula really is. So, after all that, let's bring it all home. What is the one big idea you should walk away with? Just remember this. Mass is the stuff. It's constant, and we measure it in kilograms. Weight is the gravitational pull on that stuff. It changes depending on your location, and we measure it in newtons. And it all comes back to that simple but powerful formula. Weight equals mass times gravity. So I'll leave you with one last question to chew on. If you were to take a trip to the moon, where gravity is way, way weaker, what would change? Your mass or your weight? Think about it. Is the amount of stuff you're made of changing, or is it just the pull on that stuff? Thanks for tuning in to this explainer.